Hello. Today we're going to talk about arithmetic sequences, and let's remember what an arithmetic sequence is. It is one that has a common difference between any term. So let's say we have 1, 4, 7, 10, so on and so forth. You take any term, subtract the one before it. So 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. This indeed would be an arithmetic sequence. We call this value right here the common difference. So this would indeed be an arithmetic sequence. So let's look at these first ones and determine whether or not this is arithmetic. If so, we can find the common difference. So let's look at number 1. So we take 8 minus 10, that is negative 2. 6 minus 8 is negative 2. 4 minus 6 is negative 2. 2 minus 4 is negative 2. Yes, arithmetic. And the common difference is negative 2. Whatever that value is, first term minus the second term. All right, let's check at number 2. 4 minus 1 is 3. 9 minus 4 is that is not going to be arithmetic. Okay, actually what this is going to be quadratic, which because if you see that would be 7. So we see there's 3, 5, 7. The second layer of differences is 2. If the second layer of differences is consistent, that's quadratic, but that's not what it's asking. It's asking is arithmetic. Nope, not today. Not arithmetic. And this one, 4.3 minus 3.7 is 0.6, 0.6, 0.6, 0.6. Yay, it is arithmetic. And the common difference is 0.6. Okay, on these we write the first 4 terms of the sequence and determine whether or not it's arithmetic. Remember I talked about arithmetic being similar to a linear function that looks like y equals mx plus b. So if we have a common difference, that's also going to be your slope. That's what you're going to be able to tell if it's arithmetic. So this indeed looks like y equals mx plus b, looks like a linear function. So I'm going to probably say it's arithmetic. Let's just go ahead and figure it out anyways. A sub 1, a sub 2, a sub 3, a sub 4, the first 4 terms. Each of these terms is a function of its position, so you simply substitute its position in for n. So it's going to be 8 plus 13 times 1, 8 plus 13 times 2, 8 plus 13 times 3, 8 plus 13 times 4. All right, let's see what we got here. So we got 21. We got 26 plus 8, which will be 34. We have, what we can see here is going up by 13, right? Which is the slope if it was a linear function. That is going to be our common difference. We'll find out after we're messing around with these things a little bit more. So we end up with 47 and then 60. So the first 4 terms of this sequence right here are these right here. And the common difference is indeed 13. Yes, arithmetic. Common difference is 13. By the first 4 terms for this one. A sub 1, a sub 2, a sub 3, a sub 4. Substitute in 1 in for n, 2 in for n. Each term is a function of its position. So we end up with 2 to the 0, 2 to the first, 2 to the second, and 2 to the third. Anything to the 0 power is 1, 2, 4, 8, 2, 4, 8. You can see obviously that there's no common difference. 2 minus 1 is 1, 4 minus 2 is 2. So there's no common difference, but thus not arithmetic, but these are the first 4 terms nonetheless. Now this one you might say, well, it doesn't really look like it's going to be arithmetic. But however, if we distribute this 4 out, you don't need to do this, but I'm just going to show you. 3 minus 4n minus 24 ends up being negative 4n minus 21. Now it does indeed look like a linear function with a slope of negative 4. But I bet you the common difference is negative 4. So a sub 1, a sub 2, a sub 3, a sub 4. Each of the function of its position. Negative 4 times 1 minus 21. Negative 4 times 2 minus 21. Negative 4 times 3 minus 21. Negative 4 times 4 minus 21. Okay? So we get negative 25. We get negative 29. We get negative 34. And we get negative 38. Negative 29, negative 34, and negative 38. Lo and behold, negative 4 is indeed our common difference. It is arithmetic. Okay, now for the formula for the nth term of an arithmetic sequence is this. A sub n, the nth term is going to be the first term, a sub 1, plus the common difference times n minus 1. This will give you the general formula a sub n. Okay, so let's see how this is going to work. So a sub n equals a sub 1 plus d times n minus 1. Right here they give you all the information you need. So a sub 1 is 1, common difference is 3, and you're going to include n minus 1 because we're coming up with the formula for this. And remember, each term is a function of its position, thus n is going to be part of the formula. So I'm going to distribute this to each one of these, so it's going to be 1 plus 3n minus 3. So a sub n equals 3n minus 2. Okay, so that is our formula. You can find whatever term you want. The 100th term of this sequence is 298. Simply substitute in 100 in for n. You get 300 minus 2 is 298. So the 100th term is 298 of this sequence. Okay? Alrighty. Alright, so now we're trying to find a sub n on this one. Remember, a sub n equals a sub 1 plus d times n minus 1. However, this one right here, and this one right here aren't arbitrary, nor is this n and this n. So since I'm given the third term and the sixth term, what I can do is, instead of having a sub n equals a sub 1 plus d times n minus 1, a sub 6 equals a sub 3 plus d times 6 minus 3. Because this matches with this, so therefore this 6 would match with this one. This 1 matches with this, so not just arbitrary, this would match with this. So I plug in 85 equals 94 for a sub 3 plus 3d. So 6 minus 3 is 3 times d. Negative 9 equals 3d, so d equals negative 3. Now when I come up with a sub n equals a sub 1 plus d times n minus 1. But you don't have to use the first term. I can use the third term or the sixth term if I feel so inclined. As long as this matches up with this. Plus d times n minus 3. Alright, so I'm going to use the third term, which is 94. And our d is negative 3. Minus 3 times n minus 3. Distribute this to each one of these. A sub n equals 94 minus 3n plus 9. So a sub n equals negative 3n plus 103. That is our nth, that is our formula, our definition for the nth term of this particular sequence. And we do the same thing on this one. Okay, but we have the 9th and 14th term, no big deal. Instead of a sub n equals a sub 1 times d plus d times n minus 1. This matches with this matches with this, so we're going to go a sub 14 equals a sub 9 plus d times 14 minus 9. So the 14th term is 195. The 9th term is 120 plus 5d. 75 equals 5d. So d equals 15. Then we're trying to come up with the nth term, so once again, a sub n equals a sub 1 plus d times n minus 1. But it's going to be a sub n equals a sub 9 plus d times n minus 9. Because this is not arbitrary, it matches up with that one. So a sub n equals 120. Our difference is 15, so plus 15 times n minus 9. We distribute this to each one of these. A sub n equals 120 plus 15 n minus 135. And so a sub n equals 15 n minus 15. Peace.